Okay, Dubey.
Yeah, good evening, sir.
Okay, so for which organization you are preparing?
Sir, I'm preparing for UPRVNL, the thermal power plant in UP government.
Okay, tell me one thing. In the fault calculation, why we generally ignore the pre-fault current?
Sir, because of the offset, sir, ideally, sir, what we take is that before the fault, the system must be working in a condition which is stable, and uh, we consider it as the voltage as unity, and that's why only for making our calculation easy.
Mm-hmm.
Uh,
Anything more apart from this?
Sir, other than this, sir, sir, we usually, sir, ignore all kind of effect we take as our generator and other devices are in the stable working region only. Like they are not getting any kind of effect, and also before this, before pre-fault conditions, sir, depending, no, sir, only I think this much is that I can recall at the moment.
Okay, when you enter into the power generating unit, right?
Okay, yes, sir.
What is the first thing? What is the first thing that you that you first look at it?
Sir, definitely there are big, combustion, boiling boilers and all that. These are actually big in shape. That is the thing that will come, or the smokes coming out from those things. That is
What is the
the
efficiency of thermal power plant?
thermal power plant has their efficiency from nearly 40 to 50% only, not more
Mm-hmm.
than that.
And about the nuclear power plant?
Nuclear power plants, sir, the efficiency goes high, nearly around 60 to 70%. Sir,
Okay, when we okay
huh?
when we go through this renewable energy like the solar, hydro, wind, why the efficiency goes so much down when compared with the non-conventional source of energy?
Sir, you can you repeat the question? The voice was breaking.
When compared with the conventional source of energy
Hmm.
with the non-conventional source of energy, why the
Mm-hmm.
efficiency goes so much less?
Sir, the actually, sir, the non-conventional sources of energy that we are actually utilizing, like thermal power plant and other. Uh, Sir, these are actually the number of procedure and steps. Even, sir, if you talk about hydro, then it is only some seasonal thing. When there is a surplus supply of water, then only we can utilize it. In case of thermal power plant, the procedures are like preparation of the fuel, then preparing of steam, and then converting into one form to another form. That is actually taking a lot of our energy at every step is decreasing only. We are just converting it in one form to another, and there is a lot of loss of energy which we are unable to collect back. Whereas compared to other conventional sources of energy, the wind, the tidal, in these kind of energies, the number of steps is actually lesser than compared to other. We don't require a large plant and all that for converting, whether it is a simple solar system. We only require a plate, and the conversion of energy is directly from the electrons.
Okay, so what is the efficiency of solar and wind?
Sir, the solar has the efficiency nearly, sir, 80%, and wind is also, sir, 70 to 80% only.
80% efficiency.
uh, yes,
Do you
sir.
see?
And sir, as far as I've read, it is higher in efficiency than our conventional. So yes, sir.
If it has a higher efficiency, then why we generally use the term the microgrid synchronization? Why the term micro has been used?
Actually, sir, that is due to the installation issues and also the availability of wind. And it is like the height of wind plants that one require and the installation cost, all that. It is because of this only that we are now targeting the micro uh, power generation thing. Even this is the same case with hydro also. So that is also like wherever the water supply is there, good
Okay,
supply is
okay.
there. Hmm.
Okay, you're in the wrong track. Tell me one thing. What is the role of economizer, and what are the gases that the economizer generally hold?
Uh, Sir, economizer is actually device which is installed near the condenser or the boilers. Sir,
Mhm.
it actually reduces the energy consumption, and it is like it is useful in, sir, preheating fluids, sir. So it is kind of like in our boilers, so there are multiple steps. Like we have equalizer, we have superheater, and we have preheater. All these things combine to reduce the energy of overall procedure.
Okay, so economizer is just the heat exchanger.
Yes, sir, kind of.
Mm-hmm.
And sir,
To improve the efficiency of the boiler.
yes, sir.
Okay. Why it is said that economizer is useful in therapy?
Sir, in what?
In therapy.
In, sir, I have no idea about this thing, sir.
Okay. How we can generalize, mm, and how we can regulate the economizer efficiency?
Generalize or, sir,
Regulate. If suppose economizer is not there, then what would be the result?
sir, all the heat will be, all the fluid and everything will be done by boiler only. Like
Mhm.
heating of the water from its below saturation to above saturation, everything will be done in that thing only. So
Okay,
that's
have you heard the term supercritical power plant?
super critical power plant. No, sir, I have.
Not understand. Okay, in the switchyard, what is the role of earth mat?
Earth mats are actually before when we are constructing a switchyard, then during the point of construction, we usually install a earth mat below our switchyard. So and we provide the grounding to this earth mat only. Like it is a kind of net that we have at particular depth in our earth, and we connect the wires to the devices wired to it. It provides a path for the extra current or the lightning to flow through it in the ground.
Okay. If suppose in the transmission line, if the earth wire is not there,
Yes, sir.
then which protection is disabled?
Which production is disabled?
Yeah.
When
Yeah, where this earth wire is being placed?
sir, from earth fire. Sorry, sir, I cannot recall at the moment.
Uh-huh. Suppose for the case of any power plant, right?
Mm-hmm. Yes, sir.
The unit of alternator, what is it?
Sir,
Yeah, what is the unit of alternator?
the rating of alternator.
Hmm.
Sir, 11 kV or sir, 33 kV. This kind of alternator is only being used.
In kilovolt, we are measuring the alternator.
KVA that we are using.
kVA are there. Good. But the rating of the power plant, it is in It is in watt,
Okay, sir.
either megawatt or gigawatt.
Yes, sir. Because we are considering about the actual power only, not we are taking considering the reactive power.
Okay, what is meant to be the actual power?
Sir, uh, the it is the component of our total power that
Mm-hmm.
we are utilizing. It is not going in for generation of like magnetic field and all these things, sir. So it is like we are representing the our total power in the terms of P plus JQ. So the term P is actually the actual power that we are considering, and we are mentioning our power plant in this terms only.
If suppose, okay, have you heard the term negative sequence relay?
The negative sequence, yes, sir, I have heard about it.
Okay,
Uh,
where it is used?
it is used in alternator only, sir, in case of failure of excitations.
Failure of excitation. Okay, then where does this Moho relay is being used?
More or less, sir, it is also being used. Sir,
Mm-hmm.
uh,
Namely,
sir, more relay is also used in transmission lines also. Actually, sir, more relay is also kind of this thing only. It has inheritance directional property, and even in case of negative sequence, the direction of our excitation will be opposite to our the sequence that we have. So that is why we are considering it in the failure of excitation.
so in a ring system, does this Moho relay is being used or this negative sequence relay is being used?
Sir, in where? So at which instance you are
So
asking?
negative, okay, negative sequence relay, it is being categorized in direction relay or non-directional relay?
Sir, it will be in directional relay only.
Directional relay. In any looping, which law will follow for any
Uh,
ring distribution system?
Sir, like those at from near the generation point, we are having non-directional, and it depends on after that. Like we keep on putting it directional, and
Suppose if there is if there is a fault occur in any system,
mm,
then what is the sequence of the circuit breaker to operate?
sequence of circuit breaker.
Hmm.
Uh, Sir, we use time grading thing for this. Like the nearest one will get open first, and then we calculate time for other relays also. Uh,
Hmm.
we do grading system, and depending upon that only, like the one near the uh, generation point will be opening in the last, and the other coming in between will be opening first. So it all we see the number of relays that are being installed, and after that only we calculate the time for each of them.
Okay. Time is an issue. Okay. Suppose zero current switching. Have you heard this stuff?
Zero one. Yes, sir. When the current is passing through the zero value, then only we try to operate our circuit breaker and relay.
Okay. So does all the things are related or zero sequence is something different?
Zero sequence is different, sir, and zero switching is different.
Okay. So which type of circuit breaker we are using this zero sequence?
Uh, Sorry, sir, I'm no idea about this.
Okay, Dubey, listen. The performance was good. So the question will tough, not a problem. And the thing is that the question will be asked from the generation part. Okay. So
Yes, sir.
one thing I want to give you suggestion. I've not asked about the boiler efficiency. So please go through this. Okay. And
Yes,
also
sir.
in the hydropower plant, Kaplan, Pelton, furnace, they are the part of mechanical, but we are just studying electrical also. Because they will
Mm-hmm.
ask, okay,
Yes, sir. Yes, sir.
boiler, okay, in the thermal and the for the hydro case, we are also utilizing this. And the coal base, so type of coal, how the coal is, which type of coal is being best, and how the process of the coal is being generated. Prime mover,
Mm-hmm.
okay, prime mover being the
Okay, sir.
major concern. So they will ask the question on the prime mover also,
Mm-hmm.
right? How the speed is being regulated and how the speed is being maintained constant. What are the system?
Okay, sir. And sir, related to the efficiency and also,
Yeah,
like,
efficiency. See, you will get wrongly.
okay, sir.
Flyball governor. In the flyball governor, uh, see the we are in the flyball governor. We are regulating the speed.
Mm-hmm.
Okay. Yeah. So in the case of over and under with the mechanical uh, with the mechanical system is being designed with the steam
Mm-hmm.
power is being one that is said to be the flyball and see they will ask the corollary question, the one question that I've asked in the previous interview, synchronous
Mm-hmm.
condenser and the flyball.
Yes, sir.
Okay,
Mm.
so these are the two different things.
Okay, sir.
And in the last thing, the efficiency of a solar power plant is only 15 to 18, 15 to 20%. It is not
Solar plant.
80%.
Okay,
Yeah.
sir.
And the efficiency of a wind power is also very much less uh, because the terms of intensity that we require is not desired, or we're not getting. Right. That is in the case of uh, uh, what you say as a thermal power plant, because in where we are regulating the speed or intensity of the stream,
Mm-hmm.
right?
Okay.
And all the question is okay.
Yes, sir.